Hello and welcome to our webinar series, Reduce Risk with Risk, Designing and Maintaining Secure Embedded Linux Devices with Advantech Risk Platforms. I'm Teresa Kisha and I am your host for today's session. With me today from TimeSys are Maciej Halasz, Vice President of Technology, and Akshay Bhatt, Security Architect at TimeSys. We also have on board with us again today Jason Zhu, Risk Product Manager at Advantech. Today we move on to session 4 in the series, which focuses on security in production, updating and deploying software over the air securely. Before we begin the presentation, I'd like to take just a minute or two to mention a few things. First of all, I'm very excited to announce that earlier today, TimeSys, released our TimeSys Threat Response Security Technology Product Protection Solutions. It's a mouthful. It's Trust, T-R-S-T for short. Our Trust solutions include products and services that enable developers to implement security best practices in the design of their product and to maintain the target security posture throughout the product lifecycle. Maciej is going to give you a quick overview of the offering a little later in the presentation. But if you'd like to learn more, you can do so. You can learn more about our Trust solution at timesys.com/security. Next, this session is being recorded, and the link to the recording, along with a link to today's slides, will be emailed to everyone within the next business day. In order to keep within the time we've allotted, all attendees will be on mute during the session. Following today's presentation, we'll have a 10 to 15 minute Q&A to answer any questions you might have. If you want to or would like to ask a question, simply post it via the questions window panel, and Maciej, Akshay, or Jason will answer it during the Q&A. And finally, after today's session, one lucky attendee will again receive an Advantech RSB 4411 SBC, Compliments of Advantech. Everyone who's in attendance today will be automatically entered for the giveaway following the session. And the winner from today's session will be notified by email. So with that, I'd like to say good luck to everyone, and I'll now hand over control to Maciej to get us started. Thanks again for joining us, and I hope you enjoyed today's session.
Thank you, Teresa, and welcome everyone again. Maciej Halasz at this end, and I'll take you through a topic of over-the-air updates, or actually software updates as a topic today. But before we jump to that topic, I wanted to do a quick recap from session 3. Last time, Akshay was talking about encryption of data and how to protect like proprietary information, data, but also perhaps like your own information, algorithms from end user. And with Advantech hardware that's equipped with IMX6 processor, there is a number of solutions that assist with protection of data. And we discussed secure key storage that was used to store the keys used for encryption. Akshay was also talking about trust zones and T and ARM architecture. And we also have discussed use of accelerated crypto algorithms to assist with the encryption of data. So all those features are built into a hardware, and they add to security of a designed solution. But if you have additional requirement to store additional keys, to store additional security information, a use of trusted platform modules can be helpful. So we also talked about this last time. Okay, so before I jump into talking about the software updates, I would like to pass the control over to Jason.
Hi everyone, my name is Jason Zhu. I'm from Advantech. I'm in charge for the risk product managers. And today, who for you guys didn't attend the last three session, I just want to give you a brief introduction of Advantech and what we do and what we're capable of. Okay, Advantech is founded in 1983. It's been public on 1999. Right now, last year we reached 1.4 billion. We are very healthy and very profitable company. And we have 8,000 employee or worldwide, and in United States over 500. And we have three facilities in U.S., one in Cincinnati, one in Irvine, California, and one in Milpitas, which is our manufacturer and design house in Milpitas, California. We have growing very fast in past like few years. And for the risk product line, we're also doing pretty good job in the past few years. From start to right now, it's about like a couple millions revenue right now. So the reason we are so exciting about the risk platform is we cooperation with the chipset company, we cooperation with ARM, we cooperation with NXP, Qualcomm, Texas Instruments, and we're trying to develop our standard unified solutions for the risk. Everybody talking about risk, talking about low power consumption, talking about chip price. But with Timesys help, like we doing ecosystem partner with Timesys, they are very expert on the software side. We're trying to build a standard unified solutions for peripherals, for security things, and it's like we're not focused on the hardware anymore. We're focused on bundling hardware with software and provide overall all-in-one solutions to the customers. Here it's key factors like what we do in the what we do. Okay, here's the key factor of what we do on ARM business is successful. In the past, we as you're showing on the below section, we have a different type of platform from the developing board, the module, the 3.5 inches single board computer, to the intelligent system, the gateway, and also we are doing some pre-certified or pre-testing wireless module peripherals like display storage. From software side, in the past few years, we provide standard BSP. We provide Advantech bootloaders, and we guarantee longevity Yocto and Android BSP upgrade. But that's not enough for today's world. So that's why we cooperate with Timesys, and Timesys is good at and they are capable of building engines, custom OS, driving porting, and the most important things is security features like security notifications and firmware updates if anything bad happens. Also, we provide any ODM capability with Timesys like Security Blue or some big projects. Data protection. Data protection always the key for the not only for the risk platform, also for the x86. But for the risk, data protection is extremely important. We are doing the security notification because data protection is so important. The first area where first a vertical market is let me give you some example of this. The city kiosk is our risk product selling very good on the city kiosk vertical market, and the cities are working on one thing like public Wi-Fi, like better traffic management, driverless city bus, not just a kiosk. that connect people with city events, nearby restaurants, and emergency services. So all the help along with information collected from a resident. In a time where data can be breached by hackers or backdoors left open for the data thieves to walk in and ransack the place. Some people are surrounding the alarm on the smart city because of concern about data privacy. So we're trying to build a security notification on all the ARM-based product for the city kiosk or smart city. Medical. Oh, medical is another things we'll mention about breached and the different things that involve the medical data are on the rise in the past few years. According to the report, criminal attacking health care has increased by 125% since 2010, and now the leading cause of medical data breaches. So for the medical customer, they are more focused on the on the on the data protection, including the cyber security and also so security notification is very good and is very popular for the medical customers. The third one is government. Without doubt, government we have been recommending all the government national security IT system make use of the TPM or we call Trust Platform Module, a hardware-based system security features, which is widely available on enterprise-grade tablets and laptop. It's a microcontroller that securely store encryption, keys, password, and certification. Of course, the government needed security features and security notifications too. So data protection is a key to the government. Without doubt, the military is another vertical market we are more focused on. We're selling a lot of things to the military things, but they require TPM, they require ECC, and the data protection is the key to the those above vertical market. And here is the full range of item access-based product like Advantech offer. As you can see, we offer computer module on different form factors from a hardware perspective, like Q7, Smart, and RTX, which is Advantech proprietary form factor. It's smaller than Q7. It's around 68 by 68, and it's portable pin connector, give you a ruggedized solutions, especially for military or any outside customers. And we offer 2.5 inches single board computer, 3.5 inches single board computer, also the mini ITX form factor, which is popular form factor for ARM-based product. Next, we have a box computers. We call UBC series. It's for digital signage for any other vertical market, or EPC series. Where we more focus on the IoT vertical market. Like I mentioned before, we have all the four computer module, all based on Advantech 6. And we have another 3 single board computers all based on Advantech 6. So everything I mentioned before and I mentioned about all the 6 product we have is will building the security notification that Times is provided. So we not only offer the BSP, we not only offer the user manual, the bootloader, and the longevity of the software anymore. We were adding the security features. We are adding a certificate notification. We're adding the trust zone if the customer need. So we bundle with Timesys. We bundle with System. We offer this security notification for trial version for 3 months, so customer can easily get benefits of it. If they need it, they can still doing the subscription with Timesys or with Advantech sites. To summarize up, we not just Advantech and Timesys are not just the ecosystem partners. We are focused on the hardware. They are software company, and we bonded together. It's like a win-win situation. We offer longevity. We offer like Advantech standard revision control, design service, and Timesys provide security solutions, engineering service, and fast support. So conclude my presentation today. Back to you, RJ.
Thank you, Jason. Great. This was fantastic. As you have seen, the hardware that Advantech is making available, that's based on RISC processors, comes equipped with many different security features that you can leverage directly in your products. And Advantech and Timesys, we are partnering to make this much easier on you to adopt the product, to adopt the IMX6 Advantech solution with security features directly in your design. And today we are talking about over-the-air updates or software updates in general. And the agenda is we will start by discussing why do we need the software updates. We'll talk about what to update in a system, in an embedded target Linux system. And we will talk about software update options. That's going to lead to a discussion on available free open source frameworks, which are commonly used currently in such deployments or in implementations of software updates. Then we're going to talk about security around the software update, and we'll finish today's discussion talking about the server side of the software update process. Okay. So there is a giveaway, which Teresa already mentioned in the beginning. So without further ado, let's jump into our presentation on the software update. We've been using this picture that you see in front of you for the past 3 sessions, so it's very natural that I bring this up again because it describes the complete security that you would typically look at when you design security into your device, and then when you deploy the device and you want to stay secure, right? So we've covered pretty much all the aspects already, except for the software updates. And this is the primary topic of today. If you did not have a chance to participate in prior sessions that we've held on those various topics from the last slide, they are available, they are recorded, so you can always watch them at your convenience. So first, let's talk about environment of an embedded device. When we set up an embedded device, where does it live? And what's so important about that environment that we should care about? The first one is power. Many of the embedded devices are using batteries. Some of them are connected to the main grid. But power can be sometimes unreliable. So those devices can go down at any point in time without any warning. So when I'm thinking about software update, this is important to me, right? Connectivity is also very important because many of those devices are very remote and I need to be able to connect to them somehow. There are different protocols that are in use, Wi-Fi, Bluetooth Low Energy, LTE, but some of those connections can be troublesome, and sometimes bandwidth that we desire for software update is not sufficient. So that is something to consider or think about. In many situations, such as this camera that you see in the slide, access to those devices is limited. So I have to take that into consideration as well. And once they are deployed, they are staying there for 5 to 10 of years. So I have to think about it when I'm building a product, because software update should be part of it, right? So that's on the target device side. On the server side, the situation is very different. Why? Because server side that pushes the updates to those target devices, let's say, then typically is a very controlled environment. It's secure. It has a very or much more reliable power and network connectivity with fallback, and it has an IT department that's in place and is looking constantly after the healthy performance of those servers. So I think that there is more challenges on the target side in the environment than on the server side, but that's something that we have to keep in mind. When we think about software updates, what does come to mind? If you're a Debian, Fedora, Ubuntu user, immediately package approach to updates pops up, right? If you want to update or upgrade a functionality in your Ubuntu, you use a apt-get and you update that particular functionality. The challenge with this approach is that there is a package dependency, a hierarchy. So when you update a specific package, the entire dependency tree gets updated, which well pulls in more and more information, but it updates certain portions of your operating system. This entire process is driven by a set of complex scripts, but in the end, there is no validation that the update of the software is still keeping your operating system stable. So if I reboot my system, it is possible that I may not be able to get into a shell, or I may not be able to start my application that I previously was able to. So it may be sometimes difficult to roll back some of those updates. Another challenge with this approach is that there is a database behind the package list, the database that keeps the information about the packages installed as well as the dependency tree. Which, when you think about embedded space situation, that may be challenging because we care about the footprint of the device because it may affect other requirements such as boot time. So why do we need software updates? Because when we design a secure device and we deploy it, that doesn't mean that I'm secure, right? Over time, as I showed you in session 1, I believe, there is quite a few of security vulnerabilities that are being reported. So security definitely would affect how my device is recognized or is performing in a field. And also, end users and companies are more aware of and concerned about privacy, about what data is being or is available out there and who can access it and how. So those are driving the need for software updates, which can not only improve the security of a device or keep the device secure over time, because once I have the secure device, I have to push out updates just to get the new security patches rolled out into my devices. But I can also, through security update, manage new features, performance of the device in the field, and also can fix some additional bugs if they are reported by end users. So definitely a software update mechanism is very necessary. What are the requirements for software updates? It has to be secure. Just by designing an update mechanism into my product, I cannot create another attack vector. I cannot allow this interface, new interface that I'm opening up, to be a vulnerability. So that's definitely an important aspect. It has to be atomic. If I roll out an update, it has to be installed completely, or the installation should not be performed at all. In case there is a, I don't know, power outage or the installation fails, I need to have a mechanism that allows me to go back to a last known good state. The update has to be capable of updating all aspects of my software. So Linux kernel, bootloader perhaps as well, root file system, all aspects of it, as well as application. Frequency is another requirement that we should look at because that, combined with speed of an update, can drive the specific framework or method that we're going to choose for the software update mechanism for our product. Okay, the more frequently I push the update out, perhaps there's an option that would limit the amount of data that I'm pushing out. Okay, so those are the requirements. Now, what to update? Well, so we have customers that want to just update a file, and the file can be an application or Linux kernel, or any part of the file system, really. This is typically managed by a custom process, can be developed specifically for a product, and there are open source techniques, which I'm going to mention a couple of them today, which can be leveraged for this. We can update a feature. So again, we're going back to Ubuntu and more mainstream Linux kernel way of thinking about updates. But this is, as I mentioned earlier, not very optimal for an embedded device. Why? Because there's the database behind it, because the entire update process is kind of complex. It doesn't guarantee that the update is going to keep the device in the workable state, right? So what is the most commonly used way to update software in a field in the embedded space? Well, many customers of ours are updating the complete file system in a single complete image. And this is, again, by far one of the most common approaches to rolling out software updates in the field. The other very common approach, or very popular approach nowadays, is a technique of atomic differential updates. It is kind of a very clever way of managing what you're pushing out to a device, limiting the amount of data that crosses the network to your device. And that way I can address perhaps the requirement of low bandwidth, available low bandwidth for updates. So I'm going to describe those techniques in more detail today. And then if you manage your application already and by using containers, Docker containers are quite popular nowadays. This may be one of the ways in which you could roll out also software updates, but there needs to be certain infrastructure installed in the target system to, of course, accept the containerized approach to software updates. We also have to look at software updates from a perspective of how they are being performed. So there is a local or localized approach to updating your software. And what it means is that there's typically a person in front of a device with physical access to a device that can open up access ports and load software onto it. Pros of this approach is if something goes bad, there's typically other software on the local PC of that person that can be used to recover the device much easier. And once the update is installed, it's very easy to validate that the correct software is running. It's not very scalable because if I have to send technicians to update 1,000 devices, how many technicians do I need to have on staff, right? It's also a time-consuming process. So if I do a frequent updates, it's not very, it's very expensive way of keeping the software updated on my devices. So the other approach is using over-the-air updates. In this case, we don't have a person accessing a device. There is some sort of a server that can push updates to many different devices that are connected via one of the network technologies. So by not having a physical person in front of a device, I'm making this approach more scalable. I don't need to have anyone climbing ladders and jumping through hoops to get to a device, opening up the device, right? So that's a good thing about over-the-air updates. Cons are that if something goes really wrong and I need to troubleshoot the device, I'm limited in my options, right? I can't reflash the entire device, the entire NAND flash, for example, or swap the SD card easily. The cons is also that I need to have in place a server that manages pushing the software out to those devices. Okay, so talking about image update approach. So I have a Linux kernel, the root file system, the application, and it's all kind of bundled into one image. And you can see here in some of those graphics that I have Linux image 1 and Linux image 2. So there are approaches that use the symmetric approach, where you can have an active Linux partition to which you boot. Once you're in that first partition, in that first active Linux instance, you can use some of those open source techniques to access another set of partitions and store a software update image into that second partition. And once that happens, I can toggle the active flag. So switching the second partition, the updated partition, to be active, and then I can reboot. So if the system reboots, it should boot into the newly updated partition, and then I can perform that same process to the first partition, right? So this is this symmetric way of updating partitions. I can have third and fourth set of partitions. It's not limited to just two, but this is just to show you how this process would work. The asymmetric approach assumes that there is a recovery image. So if something goes wrong, I have a way to reboot the system and fix the problem. But the recovery partition is typically read-only. So how do I update it in the asymmetric approach? I simply reboot the system into init.ramfs, so file systems that's only in memory, and I update the active Linux image partition from there. And then I reboot again, and I boot into the new image that's in that Linux image partition. That's the difference. But this allows me to fall back into a last known good software partition and recover the device. Example technologies include SWUpdate. Android also is using this type of approach. The second approach is atomic differential update approach. So it applies a set of rules to basically update the file system in place, but the updates are done using deltas, binary deltas per modified file. So I can update just one binary file in the root file system using this approach. This allows for smaller data transfers, and of course, because less data is being sent, the updates are faster. They can be very quickly deployed to a large network of devices, and the rollback is also fairly straightforward and can be performed on demand. Technologies that use this approach include the OS3 and something called SWUpdate. I have also a nice graphic here that describes this approach. So this here represents the storage device. The light blue color represents the storage device, such as an SD card or NAND flash, and I have two partitions in there. In the first partition, I have a Linux kernel and init.ramfs and something called environment file. In the second partition, I have a file system. And this is again a storage device on a target. Within that root file system partition number 2, I have something called sysroot repo, and then I have deployment increment 1, 2, 3, and actually there should be 4. Now, when the Linux boots, the bootloader can actually read the boot args and assign appropriate deployment increment. This deployment increment represents a document that describes a set of changes to the root file system. Those set of changes are then taken and let's say that there is a newer updated file under /lib/ there's a library, and I want to update just the library. This deployment increment brings in that newer updated library, but it also makes a hard link from that deployment increment to a deployment sysroot FS. So in the end, you are constructing a file system for the target device by making hard links between different deployments and the actual file system that's exposed to a target device. Okay, so that way I can control which deployment I'm mounting into. So the fallback to a previous deployment is very straightforward, very easy. Okay, and as you can see, it happens in place because the update server can push another deployment to a target root file system, and a target root file system or a target operating system itself can then decide when to reboot, when to update, and mount this updated root file system that it received from the update server. Okay, and once the main file system is mounted, I can always access persistent data. So what are the frameworks? I mentioned SWUpdate. SWUpdate is, well, supports the complete image updates, both in symmetric and asymmetric approach. It's written in C. It's licensed as open source. It supports signing images and also local and over-the-air updates. Has a quite active development community and is used in commercial settings by many customers. I've mentioned here Siemens and Bosch that use this technology in their IoT solutions. SWUpdate uses a very well recognized in the embedded Linux approach of CPIO archives, and the update file itself that it's using is called, or has an extension of .swu. On the right-hand side, you have a graphical layout of what this file would look like. The SWUpdate is a package, and it has to be installed in a root file system. It provides tools that manage locally how updates are being applied, how those .swu files are being used and installed into another partition on my local or target device. You can see on the right-hand side that there is something in green called SW description. I'll talk about this more. And images. Each image has its own SHA-256 and which is referenced directly in SW description. So SW description in a unique way identifies what images are in this container is in the .swu file. So I can have a separate set of actions that are being performed on different types of images. So if I'm dealing with U-boot environment variables, I would use different action to load them into a different location compared to, let's say, root file system. So that's what handlers for those different images do. The SWUpdate has many options, which you can configure using its own menu config screen. So that's pretty straightforward. And SWUpdate comes with a REST or RESTful API, which allows integration with other software. I'm going to talk a little bit about Hawkbit as a service solution for remote updates. In terms of SW description, you can see here is the structure of the file. There's a main block, there is a hardware association that describes what hardware this particular update is intended for, and then you have those handler blocks. One is for images here that I have in this example, and another one is for scripts. You can see different information being stored for those different handlers, but for the file system, you can see that there is a SHA-256 used here, and there's also a file name that's going to be installed in a specific device. So this SW description has to be used somehow to build this update image. And to build an update image, we can use Yocto itself. There is actually a meta layer for SWUpdate, which I'm going to mention in the next slide. But this is a recipe here that I show you as an example of how to build a software update image. And you can see here that there is a reference to the software description that is very specific to this device. And down below under SWUpdate images, you have links to different types of images that are going to be part of the update file. So I can update not one, but multiple partitions with different root file systems if I choose so. Okay. So I mentioned that SWUpdate has its own integration into Yocto. There is a meta layer called Meta SWUpdate, which you can access, and there is within that meta layer, there is a recipe called SWUpdate image, which would build a recovery deployment image. It has the definition for that. Since Yocto outputs all the images into temp deploy, you can build the custom recipe for the software update image and reference those deployment images in there. So once I have the recipe, and you can see this Advantech SWU image, which is the one that I showed you in the previous slide, I can run bitbake on it, and that would produce a .swu that I can then deploy to the target device, to this Advantech system, to this Advantech board. SWUpdate is a command, so here is different incarnations of how I would use the SWUpdate to perform a local update, as well as to access a remote HTTP server from the target device, from the Advantech IMX6 device, to pull down the SWU update for that device. Okay. So the next technology is called OS3. It's an incremental atomic differential upgrade mechanism, licensed as open source as well. It's often it self-describes itself as a Git for operating system binaries, because it stores those binary deltas in a Git-like object repository, which can then be pushed to a target device. It also has the Yocto project infrastructure provided under Meta Updater. This Meta Updater provides appropriate recipes for preparing physical sysroot, for preparing deployment sysroots, but also to make sure that the bootloader and initramfs are constructed in such a way that they on their own would be able to handle those tasks of preparing a deployment sysroot. There is a number of open source projects that are using this technique. Qt software, for example, has support for OS3. Automotive grade Linux also is using this approach. When you look at the root file system of a target device, you would see there an OS3 directory and set of folders, repo and also deploy. Under the deploy directory is where you would store the deployments. So if I create set of deltas on in the build process, and I push those deltas to the target device, those deltas would be stored here as a deployment. And each of those deployments would have its own SHA-256 checksum, which would uniquely identify the deployment. That way I can differentiate between those deployments and can identify in a unique way the rollback point if something goes wrong. The OS3 comes with its own set of commands that are also pre-installed in a target root file system to perform upgrades, to perform deployments, but also to undeploy certain deployments. The last, not least, way to do a differential update is a technique called SWUPD. It is using bundles. It's creating bundles and creates a stream of them that can be then pushed to a target device. It's licensed. This technique is also licensed under open source GPL version 2. Very similar to OS3, one of the main differences is that you don't need to reboot the target device once you apply an update. The Yocto project integration is there, but I have to say that the community, the activity around this open source project is low. So the other two aspects, or the other two portions of the SWUPD, the SWUPD client, which applies the updates on a target, and SWUPD server, which creates the bundle that is then streamed to the target device. Those are actively maintained. The Yocto integration has less activity. So security, it's important because we've been talking about security. How do you secure the device? How do you do secure boot? Now, we have the secure device. How do we verify that the software update that we want to install is also authentic and secure? Why do we care about authenticity? Because I want to make sure that the software that is going to be installed on a device comes from me, not from somebody else, right? And then the other aspect is when I receive bytes, are they representing what I'm sending? Or maybe somebody is injecting something in between. So how do I secure a software update image? And I'm going to do this quick discussion using the SWUpdate image, the .swu. If you recall, the SW description holds the information about different images in the update image in the .swu. And they are all identified through very unique SHA-256, which can be very easily faked. So if I sign the SW description, I can authenticate that all the SHAs are correct, and I can make sure that the software that I've received is really mine, okay? So how do I sign the SW description? I believe that actually in the last session was talking about using OpenSSL, and this is an example how you can use OpenSSL to generate a private key and then public key. Public key, of course, is the one that would typically get stored in a target device at deployment. And a private key could be used to sign the SW description on the server. So this signed SW description can be then attached to the software update file, and it can be deployed to the target device. The signing of those update images typically happens on a dedicated signing server. So in an infrastructure that you would be building to push the software updates to remote target devices, you would also have a server that has exclusive access to those private signing keys, just to make sure that those private keys never leave your secure domain, right? Never leave your premises. On the target device, you can use the mechanisms that are provided by the hardware to verify the signature on the SW description. We've discussed those mechanisms before. You can use the U-boot to which can access the public key stored in one-time programmable fuses and verify the signature on anything, including the software update image. Linux kernel can do that as well. You can also use TPMs and store the different keys directly in TPMs and access them when you receive the software update image. Deployment management. If you want to manage the deployment of software updates in a field, you typically are going to need information about available targets. What's the hardware revision, currently installed software on those different boards? What's the current device status, whether they are online, offline, Are they in use? Are they how much power is available from a battery? I don't want to start an update if there is only 1% of battery available, right? So then also on a software update itself, I also need to have certain knowledge. I need to know the software version, intended hardware revision. So you can imagine that there are two different databases that I have to manage on my server in order to manage my target devices. There is a couple of open source solutions. I'm bringing up here one of them, which is open source deployment framework called HawkBit, which has an Eclipse plugin. It is actually an Eclipse plugin. It's a domain-independent backend framework that helps with rolling out software updates to target devices. It helps manage those target devices as well. It has the integration with SWUpdate framework. So this is a screenshot from HawkBit. You can see that there is a list of targets, there are distributions. I can do rollouts, I can track rollouts. So it's one of the frameworks that can be absolutely used in your own software update deployments. I do have a demo for you that I wanted to very quickly show you, which is going to, showcase what we did for a number of our customers. It's SWUpdate installed on the Advantech's IMX6 board. And let me switch to a video. And I've pre-recorded it earlier. So you can see that I've booted this target device from MMC block 0 partition 3. That's from where this particular operating system is running, and here is the timestamp on it. Now, there's a web server that allows me, on the target device, that allows me to upload, connect from a web browser, and then select a local update image.swu and push it to that target device. So that's what's happening here. You can see highlighted that the image that I pushed to the target device has been verified. Its signature has been verified. And right now, the SWUpdate that's installed on that Advantech target system is applying this update to the second set of partitions. Once the update is cleanly applied, the system shall reboot, which is something that's happening right now. We've lost the connection from our web browser to that target system because, it's rebooting. But instead of running from MMC device 0 partition 3, we are going to boot from a different partition. At least we are expecting that we are going to boot from a different partition. And you can see in this log that there is something called MMC block 0 partition 2 already mentioned. So it looks like it's booting from a different partition, but let's boot all the way, and we can verify it very quickly. So here it is, mount, and you can see that we are running this time from the MMC block 0 partition 2 as root, and the timestamp is also different. So this is a quick example of how SWUpdate could be used to deploy software updates. And this is part of what our trust team is doing. As I mentioned, many of these designs are product specific. So we always collaborate with you to assist with your specific requirements for software updates. Okay, so times to security offering summary. Teresa mentioned earlier today that we have released officially the solution, and this is what it is. We offer solution for securing by design and for staying secure. Under securing by design, we offer security audits, hardening. We help with secure boot and building chain of trust for your device. We assist with device encryption and security key storage. And we also assist with over-the-air software updates. To stay secure, we have in our offering security monitoring and notification, which we offer today for free for the period of 3 months to everyone who is buying the Advantech systems. We also have update, patch, and management. And we are also offering for those companies who want to have their BSP lifecycle managed outside of the company. We offer a product, a service called BSP lifecycle maintenance, where we take on the task of monitoring the security on your BSP and applying appropriate patches that are available. So in our sessions, we have talked about security monitoring, notification, patching, as well as BSP lifecycle maintenance. That's something that we did in session 1. We talked about secure boot chain of trust in session 2, device encryption in session 3. Today, we've talked about over-the-air software updates. Last session, I guess, in this series is going to cover security audit and hardening. So with that, I wanted to show this slide, the takeaways from today, and I'm going to open up the floor for questions. I realized that we went a little bit over our assumed time, but hopefully there's still enough time to go through some of the questions. So I don't see actually the chat window. Teresa, do we have questions?
We have a couple of questions. We had a little bit, and I apologize, we had some minor technical difficulties today. As many of you may have noticed, there were a few of Jason's slides that were not visible. Not to worry, we will include a copy of the presentation that includes Jason's slides that will get emailed to everyone. In addition, we're also having a little bit of technical difficulty with our question panel. I was able to grab a couple of questions from there before we started getting some glitches. But first question here that I did grab was, can I update more than one partition in a single update?
Yes, so maybe I will take this one. The answer is yes, absolutely. If you have multiple partitions, you can update them with a single software update image. And that single software update image can have differently formatted file systems with file systems that contain different files, represent different functionality. And through for example, the SWUpdate mechanism, you can flash them into different partitions. So absolutely, you can achieve that with a single software update image.
Thanks, Maciej. And let's see, the next question that I have is, how can I verify valid software update images coming from multiple servers? Example, signed with different keys. Is it possible?
So again, maybe I'll start. Yes, it is possible. The hardware support for one-time programmable keys typically can support more than one key, but the use of trusted platform modules, TPMs, extends that even further. So this would assist or allow you to deploy multiple public keys in a secure environment, secure way. And those public keys could be then used to validate different software update images. But of course, that would have to be engineered and designed appropriately.
Great, thanks. I think we have time for one or two more questions. The next question I see is, does this technology apply to the IMX8 module as well?
Akshay, would you like to take this one?
Sure. Yeah, so all of the mechanisms with which Maciej discussed today are mostly platform independent, or rather processor independent. So for example, SWUpdate, as long as you define your partition scheme and do you want a single image, or like do you want to go with a dual image copy, all of those concepts should be applicable both for the IMX6 and IMX8 platform.
Thanks, Akshay, for taking that question. And let's see, I think we have one last one here. It looks like it's a two-part question. How do you ensure atomic updates when your microcontroller hardware requires an erase before flash method of update? And your space limited to one partition, or is this not possible?
I'm sorry, Teresa. Could you repeat that question again, please?
Okay. Yes, it's a long question. How do you ensure atomic updates when your microcontroller hardware requires an erase before flash method of update? And then the second part is, and your space limited to one partition, or is this not possible?
Actually, I know that you've worked with different scenarios with field software updates. Probably you would, I don't know, do you have an answer for this question?
So one mechanism which could be used is to have a very small image whose sole responsibility is to do a software update. That way you don't have, it doesn't have to be a large image with like your all your Linux applications. So when you want to go into this update mode, you can reset the microcontroller and then jump into this update code. And then from there, you can erase your main application or main operating system and then reflash it. It's kind of a tricky scenario, because if you lose power at that point, then you'd be stuck in this updater code, which would be responsible for having to recover in case of a power outage. I hope that answered your question.
That's a great question. Let's see, and I see two more last minute questions here. Can you run software update on a hierarchical system where only one computer in a network is connected to the server? Can it relay the update to a computer locally?
I can take that question. Yes, so that would have to be designed in. So that's what like kind of it's more of a gateway architecture where like the gateway itself can download the OTA image from like a server, and then like once it downloads and updates the gateway can then go ahead and then update any sensors or other devices connected to it. It's a case-by-case based design, which depending on how the sensors are connected to the gateway, if it's a regular like Ethernet, then you can use the same update mechanism, or if it's like some other technology like Zigbee or Z-Wave, then you might have to use what's available in the Zigbee protocol, for example, to update the sensor devices.
Thanks, Akshay. And let's see, question, is the service that you provide support to implement those FOSS tools that you mentioned?
Yes, I'll take this one. Yes, thank you. Yes, at Timesys we offer a service to help you design the proper software update mechanism for your product, and this is where our experts actually is leading one of the teams of experts in this domain. They are collaborating with you on identifying your product specific requirements, because there are many aspects to the software update process, the partitioning scheme, the technology, the technique that you're going to use for updates. Some of the questions that were asked already highlighted some of the use cases. We always look at them in a very individual way. So the team is very knowledgeable about the different techniques, different use cases, most commonly used approaches and gotchas that you can run into when designing the software update process. And we always design it through engagement at the services level. But the collaboration is the key. And actually, I do have that in my slide. So thank you for that question.
Thanks, Maciej. And let's take one last question. We do have a couple more questions. I see, however, we are running a little behind over the allotted time. So what we can do is for the questions that we don't answer, we can actually respond to you via email and get you some more detailed information. So let's take this last question, and I believe, Akshay, this is going to go back to you. This is regarding the previous answer. The question is, so then you can't ensure atomic updates with one partition?
Yeah, the short answer is yes. Unless you consider having a recovery image. So you could still have, it depends on how your partition is laid out. So if you're able to like erase X number of blocks in the partition, and like have the recovery image at the end of the partition and not erase that section of the partition, then you could still have an atomic update. But if that is not feasible on your platform, then yes, you cannot have an atomic update in that particular case. Or there is another solution where like you can have, so Ubuntu has this concept of snaps where like you can have two packages. So the way the Ubuntu snaps works is like when you try and update a particular package, then it can go, it can keep a backup copy, and only if the updated copy installs successfully, then it gets rid of the old copy. But that is done at a package level, not at a partition level.
Thanks, Akshay. That was awesome. So unfortunately, that is all the time that we have for today. I see a couple more questions, but we'll go ahead and follow up in an email to everyone. And we can also possibly even include those questions in the follow-up email so that everyone in attendance has access to those questions and answers. So with that, I'd like to, on behalf of myself, Maciej, Akshay, and Jason, I'd like to thank you all for being online with us today. We'll see you again in 2 weeks for the 5th and final session in this series, which will focus on auditing and hardening security best practices. I hope you enjoyed today's session, and have a good day, everyone. Thank you.
Thank you, guys.